For figure P5-5, we're going to take a look at using some of the other mate feature geometries to provide mates. And so I gave you earlier the hierarchy that I would rather go plane to plane, face to face, face to plane. Then we go to edges, and then we go to points. So with this, we can build in some of our geometry. We're going to be able to use the configurations as well. So I'm going to fly this out of the way. One quick note about the exploded views and the drawings is our progression is we build the parts. We make those decisions on standard parts, multi-body parts, anything that's going to be an advanced strategy. Go in and bottom up, top down type assemblies. And once we've created the assembly and we're preparing to go over the drawing, then we can create an exploded view. And the exploded view will be used in the drawing or just as a graphic as part of our process. Okay, so a new assembly. And the first plate that I'm going to bring in will still be, we'll do the spacer plate, and this is showing as a 2x2. So under the configurations, if I pick up the plate 2x2 and then open, and then we rotate. Now one thing I haven't tried, and don't know if it's going to pick it up, but if we go to the origin, pretty not snapping to the origin. It says it is, but that looks like it's kind of based on the current view, and that one's really not doing much better. So looking at it from the front, I'm just not seeing anything that really is helping me out there on the view. So we'll just make sure that when I float this, so kind of went right into to float to be able to position this, and while it's not required, again with the as we go into evaluate and do mass properties, the mass properties are going to be the coordinates relative to the default, which is the assembly origin. And if we're floating out in space, or we're fixed out in space, so to speak, then in relation to the origin, it's going to shift from whatever point. We can still add coordinate systems. We can still change that relative to, but I still just like to have a component that is ready to go. So when I was creating the plate, I mentioned that we were drawing in the front. This is the result now of, I'm going to have to float these, put them into position. If we had drawn it in the top plane and gone through the process that way, then very likely these would come in orientation. I would hit the checkbox and it would go right to origin. So if we control select the top, and I can go coincident. Oh no, I did top, so let's just cancel that. I was talking and not paying attention to what I was doing. I need that to go to the front plane because the bottom is already going, our bottom of our part. Alright, and then if we go back to assembly, just real quick, the paper clip gives us the mate. And then if I can't see or I haven't pre-selected, this is where we're going to do the fly out, and I'll go to the right plane. Okay, so we'll go ahead and accept that and close that. A Control 7 puts me back in the isometric view. I'm going to hold down the control button, left click on the part, drag in another instance. Alright, so my natural tendency would be to go face to face, face to the back of that, and then face to face, something along those lines. That gives me the best, most stable geometry. When I've gone edge to edge, there have been not too many issues, but occasionally there are issues. Now on the surface, this is able to rotate and move back and forth, and so with the faces, I'm having to select 3 faces. If I go with an edge and a point, then I get the same result. The only problem is that if there's an issue later on, it will usually be because the assembly with the pointer along that edge had some kind of issue. It lost its mind. And maybe this is a problem from 10 or 15, 20 years ago that I'm still holding on to, but I think the most stable is to go face to face and pick a strategy and stay with it. If you don't ever run into any problems going for edges and points, then stay with it. Alright, so an advantage of the configuration again is that even though I need a quad, I can drag in the other component, come over to the pick up a quad, and change it over. And unfortunately I did the wrong one. Alright, so I thought I was still pointed to that one. So let's try that again. Well, at least the mate held in that case. It didn't lose its mind. So we'll go back to the 2x2, make sure to hit the check mark, highlight, and then let's go to the quad. So back on the part, I could rearrange those and have a little better in my a little better organization in my list. Alright, so there's going to be 2 here. And so let's stay with the edge to edge. Just try it and confirm or disprove that my previous fears are unfounded. So if I go coincident, let's see what did it add it. Would have sworn I pushed. Oh, I'm waiting for it to catch up. So edge to edge coincident. Alright, that's getting it. Now this is a fairly static, and I want to say that when the problems that I've encountered previously is when I had a dynamic assembly that I was going to move or see how these components moved in relation to each other. Because of the point, if we went to an edge, no, it really can't rotate on those, but oh, and I accidentally hit transparency there, so let's go back and we'll turn the transparency off. Alright, we'll bring in another instance of the quad. So I don't know that I'm ready to give up my my fear of the edges on the basis of a couple pieces. And in large assemblies, the last thing I want to do is have to go back over and over again and correct for these mates. So I'm going to take it slow steps, baby steps at this point. Alright, so the inner insert component. Again, hardwares and fasteners are the last to come in. I'm going to bring in a bracket, and the bracket has the mate reference to it. We're going to switch over to the Z bracket, and then I can locate, and then a control select and locate. Alright, so one of the interesting things, if this was dynamic, and because of the fasteners we can start looking at it in those terms, is if I set a parallel mate, these are going to rotate together, and that starts to set up some of the motion. Because these are pegged, there is no compression to a fastener, to a threaded, to a nut and bolt type situation that is going to hold these in place. So in theory, we peg all of these together. We have the 10 by 20, we have a 10 by 30, and these guys are going to be able to rotate. Alright, so building this up into the last, one more control select, and again this was a shift in strategy for me. So let me find that edge, and we will go coincident. And coincident. Alright, so that gets the basis built. And then we're going to do that little contortionist act again. So I'm going to have some 20s, a couple 3, 4 20s, and a couple of 3s. Now, because of those pegs, I just move them and I move them back, is that I'm able to rotate, and there is my problem with the edge. Alright, so there's still another mate. Now if I wanted to truly make this dynamic, then those edges were not my first choice, or not my better choice there. Alright, so let's go back to the spacer plate, because I do want to see that move more naturally. We're going to get rid of those two. A lot of times I can edit the mates, but I don't know that that's going to be worthwhile here. So we're going to go concentric, and we'll move that out of the way a little bit. Pick up our next cylinders and go concentric. And then because those are faces, we'll rotate over and go coincident. Alright, so the more natural movement is the same as with it being parallel. If I suppressed or I deleted the parallel, this would still work. This would still have that rotation because it's relying on those pegs for its its position, its orientation within the assembly. So if I was to make the ends coincident or parallel, that would cause it to become fixed or fully defined. Alright, would bring it into position. So decisions that you have to make about the results, even with the edges, if I'd come over and brought that edge and that edge coincident, it would have had the same result, except I still wouldn't have been able to see the rotation. At least now, if I wanted this to be dynamic or needed it to, the parallels are easy to define or to identify. And if I suppress one of those parallels, I can very easily get back to its dynamic type situation. So one more thing let's check before I get away from this is let's bring it all the way around. And if I unsuppress, I want to see what it goes back in for the solution. Alright, so I brought it back. The other possibility is if it converted to the anti-aligned or the checking the mate alignment, it could have brought it back around 180 degrees. It doesn't happen very often, but if the other mates will allow it, it can happen. Alright, so for our pins, let's see, we've done the File Explorer. The one we haven't done is from the actual Windows File Explorer. So let me find my parts here. And we'll just kind of fly in the Windows Explorer here. Alright, so I'm going to stay with the peg, and then highlight, covers over the edge, that gives me the mate. I hit tab, that puts it into position, and since it's drag and drop, it's going to ask me which item. So let's just pick the wrong one for view, and how do we tell it that it's the wrong one is that it's sticking through quite a ways. Changing it back then comes to the 10 by 20, and then we can set. Alright, so what we did before is I could keep dragging from the Windows or Windows Explorer and place it, and it's going to keep asking at each time. I don't know that I want to do that every time, but if I do the control and drag, then I have to do the contortionist act of left mouse buttons being held down, control buttons being held down with my thumb, and I'm hitting the tab to reverse with my left index finger, and then let go. Alright, same as if I'm bringing it, holding down the control button, dragging the peg in, finding the edge, hitting the tab button, and releasing. Alright, and then the last ones for the peg are going to be to go to and control one more time and set it. Alright, so the two that are needed, we will go from the 10 by 20 to the 10 by 30, and with the display states active, we should also see a change in color. Alright, so not quite ready to do the exploded view. We're going to keep these kind of short and focus on the assemblies. Probably one thing is I pick up all of the pegs. The minus signs, again, are not that big of a deal, but if you want to take care of those, and letting the video card catch up, there we go. Because I'm in the very bottom mate folder, I'm going to be able to identify all of those concentric mates. And I think that's going to do it. Parallel also makes a nice bookmark there. And we're going to lock rotation. Alright, so let's see if we take that bracket, even though those pegs are locked in rotation, if I suppress the parallel, I should still see movement because the pegs are going to allow rotation even though they're staying stationary. So technically one side would be locked up and the other side not so much. Alright, so visual and kind of thinking about the solutions and the results that we want to end up with as we go along.